Hey, Mike here. Have you ever wondered how two fractions can look completely different, but they actually weigh the exact same amount? In math, we call these equivalent fractions, but I like to think of them as twin brothers, Bobby and Robert to be exact. Ooh, I'm just kidding. To show you how, let's start with one of the easier ways to get a fraction that is twin to another fraction. If you multiply the top and bottom numbers of a fraction by the same number, the result will be equivalent to the original fraction. For instance, let's take 4/5. We can make an equivalent fraction by multiplying the top and bottom by 3. You have to do the same thing to both numbers, or the fraction will not stay equivalent. On the top, 4 times 3 equals 12. On the bottom, 5 times 3 equals 15. So, 4/5 is equivalent to 12/15. Let's say we want to find an equivalent fraction for 1/2. To do that, we multiply the top and bottom of a fraction by the same number. Let's pick the number 2, even though there are many choices. So we multiply 1/2 by 2/2. Now we work it out. 1 times 2 is 2. 2 times 2 is 4. So we get 2/4. That means 2/4 is equivalent to 1/2. We can also divide to get an equivalent fraction. For example, let's take 12/30. We can divide both numbers by 3 since they are both divisible by 3. On the top, 12 divided by 3 equals 4. On the bottom, 30 divided by 3 equals 10. So 12/30 is equivalent to 4/10. We can use any number to create equivalent fractions as long as we multiply both the top and bottom by the same number. And because we can do that, the possibilities are endless. To see what I mean, look at this example. Let's start with 1/2. Now we multiply both the top and bottom by 2. We get 2/4. If you multiply 1/2 by 3/3, we get 3/6. If you multiply 1/2 by 4/4, we get 4/8. And we can keep on going. All these fractions look different, but they all represent the same value. They are equivalent fractions. Now that you know how to create your own equivalent fractions, let's look at the type of problem you actually see on a test, where one part of the number is missing. We are given an equivalent fraction, but one part is missing. So let's see how it works. We are given an equivalent fraction, 3/4 equals 17/16, but one part is missing, so we ask, what do we multiply 4 by to get 16? We multiply by 4, so we take 3 and multiply it by 4. 3 times 4 is 12, so the missing number is 12. That means 3/4 equals 12/16. But what if we have 15/20 equals 3/something? This time, we have to go backward. We ask, what do we divide 15 by to get 3? We divide by 5, so we follow the same rule and do the same thing to the bottom. 20 divided by 5 is 4, so the missing number is 4. That means 15/20 equals 3/4. So how do we know whether we multiply or divide? We don't just guess, we look at what happened to the numbers. Let's say we are trying to match two fractions. If the number is getting bigger, we are building it up. For example, if 4 becomes 60, we are moving up. To go up, we multiply. So we ask, what do we multiply 4 by to get 60? We multiply by 4. But if the number is getting smaller, we are breaking it down. For example, if 15 becomes 3, we are moving down. To go down, we divide. So we ask, what do we divide 15 by to get 3? We divide by 5. So here's the simple rule. If the numbers get bigger, we multiply. If the numbers get smaller, we divide. But no matter what, we always use the same number on the top and bottom. Thanks for watching Love Maths, and I will see you next time.